Hello there, welcome to University. Today we'll be learning how to solve this problem on geometrical progression. It says find the number of terms in a GP given that its first and last terms are 5 whole number 1 over 3k and 243 over 256k respectively, and its common ratio is 3 over 4. Can we solve this? Let's dive into it. Okay, say solution, and we start. First of all, let's write out the parameters that are given. They said find n, that's the number of terms in the GP. So no, n is unknown. They said given that the first term, which is a, is equal to 5 whole number 1 over 3k. And this can be converted to a common fraction as 16 over 3k. That means 5 times 3. That's 15 plus 1, 16 all over 3. And then we have our last term, which is same thing as our nth term, sometimes denoted by un or tn. I will say it is 243 all over 256k. What else again was given? That's our r, 3 over 4. Now that we've written out all that was given, remember the formula for the n term of a GP. It is un equal to a r n raised to n minus 1. So we can impute the values for these. We know that n is missing, so every other one here has a value. For un, we're imputing this, that's this one here, 243 all over 256k equal to, our a is what? 16 over 3k, 16 all over 3k times our r. What's our r there? It's a fraction, 3 over 4. So we can put that in a bracket. Raised to n minus 1. Now with this done, let's see how we can eliminate this 16 over 3k here. So we have our, no, we are solving towards n. So let's see how we can make n to be alone on this side without any other number. So how do you remove 16k over 3? You can simply multiply both sides by 3 over 16k. If we multiply this, let's see what will happen. So we have here 243k all over 256 times 3 over 16k equal to, on the other side, that's the right hand side, we have 16k over 3 times 3 over 16k. Then multiplying our common ratio, 3 over 4 n minus 1. Now let's observe what is happening on the right hand side. K will cancel out k, 16 cancel out 16, 3 cancel out 3. We have successfully removed 16k over 3 on the right hand side. So we have just our common ratio left, 3 over 4 is for n minus 1. On this other side, k, we cancel out k, and we can simply multiply the numerators. So we have numerators as 243 times 3 all over 256 times 16. Now can press it on our calculator to see the answer. 243 times 3. So here we have 729 all over, for the denominator, 256 times 16, 4096 equal to, here we still have our 3 over 4 n minus 1. Now, by the law of indices, we know that this n minus 1 was gotten by the multiplication of a particular base, which is 3 over 4, and itself again having different powers. The first one was having the power of n, the second one was having the power of minus 1. So when you multiply them, it becomes a sum. You can go back to your laws of indices to know what you're about to do here. So this is the same thing as 3 over 4 raised to power n times 3 over 4 raised to power minus 1. And on this side we have 729 all over 4. Observe what's happening here. This is an inverse. So we have here, let me change this. This is an inverse. So we have this first, 3 over 4 raised to power n times, for an inverse, the denominator will go to the numerator will go to the denominator. So that's 4 over 3. And here we see about 729 over 4096. Now in order to remove this, we can multiply both sides by 3 over 4. So we say multiply both sides by 3 over 4. And then we have here 729 over 4096 times 3 over 4 equal to, we see our 3 over 4 raised to power n times 4 over 3, that's this here, multiplied by this 3 over 4. This will cancel out. Please, I'm trying to break down the steps for some of us that are having problems with our basic maths operations. So what is left on this side? We have 3 over 4 raised to power n. And on this side, let's multiply and see what we have there. 2187 all over, let's multiply the denominators here, 4096 times 4, 16,384. Now observe with me that 3 over 4 raised to power all raised to power n, that means this n is affecting everything within the brackets. So we can rewrite this as 3 raised to power n all over 4 raised to power n. 2187 all over 16,384. Now from here, let's observe. We can simply equate the numerators and the denominators because the powers are both the same on one side. So we can say equating numerator and denominator. What do we mean by that? It simply means 3 raised to power n equal to 2187 and 4 raised to power n equal to 16,384. Now the question is, what value of 3 will give us this? You can check that on your calculator. I have here that n should be equal to 7. If you should press 3 raised to power 7, you get this. So let's write if it's the same here. If they are both different, that means you've made a mistake somewhere. But if they are both the same, that means you're correct. Here n, let's see, 4 raised to power 7. That's correct. So the value of n is 7. So the number of terms in this GP, this geometrical progression, is 7 terms. Thank you so much for watching this video. Please do well to like, subscribe, and share. See you in our next clip.